and we'll look at the basics of what the server is and how it relates to cloud computing. And then we'll look at it, I think, the next couple of slides. Yeah, so we'll look at that. All right. So with regards to server basics, it's more or less how Huawei and many cloud vendors use the server operating systems. Okay, so we're gonna.
Entra você aqui para bugar. Entra você aqui.
Sorry guys, I muted the other person and then ended up muting me. Yeah, sorry. I saw now on the hotspot that's me. They are muted me instead of the next person. Sorry about that. Okay, so just to go back to what I just said now, server basics looks at the PC, but in a different way. Where your RAM, you have special type of RAM that's called EC. Or I'll just double check the proper acronym. And then with regards to the CPU, you have different types of CPU.
Muted.
It can't be muted. I am still audible. Can you guys hear me? Just double checking what's happening this morning with the Zoom. Can you guys hear me?
Yes, we can hear you, sir.
All right. So I don't know what happened earlier. Okay, cool. Thank you. All right. So getting back to what I just said now, when we look at RAM, you have different types of RAM. The CPU, just to put it out there, you have the Xeon, I think it's Xeon CPU, and then with that CPU, you have different versions, different flavors, and we can look at other things in detail. And then with a hard drive, you tend to deal with SCSIs and SSDs. And those are SCSIs could also be SSDs or it could be a hard disk drive. So that is just a controller, but we'll get to that when we get to I think storage basics and those things. All right. So that is basically just server basics. Okay. Now there's other things that works with the server, and we'll go through that. All right. So servers are the foundation of all server platforms, which means that any particular cloud provider out there have a server that they run their particular operating system on. They can have a different name for it. They can keep it hidden from the public and not just saying they have a cloud OS, but not saying what they're running on. They're all running servers, and all these servers are probably all Linux servers. So in most cases, Linux is an operating system that allows servers to actually use that operating system based on its design and specifics. So with regards to cloud computing, a server basically are there to help you build all the bits and pieces together and to basically create this virtualization. Now, the objectives of today and of these topics would be to really understand what a server is, understand the type of server. So we'll look at type of servers. You get different types of servers. Um, we're also going to look at the hardware composition of basic principles of a server. So we're going to go and actually dissect the server and show you basically what all the parts is in the server. And then lastly, just look at familiarizing you with different technologies that that the server contains. Okay, so what's a server? Server basically is a type of computer, as I said, it's a PC, right? It's just a normal PC, but it allows you to run things faster. It can carry more loads, so you have more loads that you can run on the server, and also it's obviously more costly than normal computers. Where a PC would cost you around about, let's say, a good laptop costs you about 20K. A server will be plus minus starting off at 40K. So you have 40K server. That's your starting price for a server, right? And that is just the basics. That's not even maybe that's an entry level CPU. That's maybe just 8 gig RAM and so forth, right? And the more you add to that server, the more the pricing goes and the model changes, right? So it really costs a lot. And again, when we talk about TCO, the total cost of ownership, that's a big thing that people need to look out for, because you buy a server, you need to think of your total cost of ownership and your investment into buying that. Will it cost you more to maintain it over the years, or would you just want to go to the cloud? So those are kind of things that people have to think about. But okay, let's look at what servers provide to users. So again, it allows availability, and what we mean by that is that if something goes down, one particular service goes down, there's always a backup. So it needs to be, available. That's one feature that the server needs to have. The next thing is scalability. It needs to be scalable. So if you have, let's say, a server and the server needs to expand its hardware, that's the talk we talk about scalability. Could mean hardware scalability, but that's scalability. Um, You also have to look at manageability, right? How can you manage the server? Is the server manageable? Can you do certain things with a server? Like, can you do reports? Is there alarm monitoring built into that? Because that's what the server stands out for. To have a built-in monitoring system. There's alarms if the CPU runs too high on power or on power consumption, which means it can overheat. Those kind of things, right? And then usability, it needs to be easy to maintain, and then you as the whoever's the technician of that server must need able to really maintain it and restore if anything goes wrong, because remember, it's hardware, anything can fail with hardware. And if you don't have the right hardware and you don't have the right parts for that particular server, you obviously have to maintain and get more better parts, or parts that are compatible with the server. And then also it needs to be reliable, right? So reliability is also important. So hence why I said that when you start the server up, clients will use the server, and so you need to make sure that the server runs for the period that you say it's going to be available. So availability, normally we talk about 99.999 I think percent, right? And what it means is that the server will be that amount of time available. If a service not in the 99% range, it means it's not available, and it means that your clients are not going to trust you using that resource. So you need to guarantee that particular availability. Right. So those are just the different digits and the features of the server. And now we're going to look at certain server types that you get, right? So you have, and some of these you would know, you have a file server, and so your file server is basically used for client to server relationships. You might run a program on the server, and then basically you want to perform different tasks. So that's the kind of file server which deal with clients. So that's normally your client, and then the client server then connects to the server application on this other side. So that's kind of relationship you have with the file server. Again, then you have also a database, and a database is where you would want to run your storage and your data of your normal database that you would run, right? You have different types of databases. Okay, you get MySQL, which is common for online databases. And you get also the normal SQL server, which Microsoft is common. So Microsoft normally has SQL Server, and you also have different type of databases. Which nowadays you have NoSQL, which means that I just want to rewrite that, which means that you have to you can store your data in any type of format without having to worry about the resources and the type of files that's running on it. So I just want to erase that part there. Right. So NoSQL is basically a type of data structure that you use. So it's basically called NoSQL. Right. That's the type of databases, and you have different type of formats, different file types and structures that goes in there. And that's also part of what makes a server stand out. It's not your common normal database that you would run on your PC. On email side, a server should be able to handle particular email services. And when we look at type of email service, it could be a mail server, it could be a SMTP server that forwards mail, or it could be a server that receives mail and stores the mail locally onto that particular server use case. And those are also things that you can use a server for. Web server, that's more common. So you would have your web server running on top of it, and you would actually provide a web pages to clients to use the server. And that's also the client server relationship. And an application is you might run an application on top of maybe a Java or JavaScript application, whatever you run on it as a developer. Those are things that you can run on top of the server, right? You can also make your server act as a DNS. And so what's a DNS is basically it's basically just a server that takes your IP address. So let's say you have a 192.168.1.1. That's your host, right? So that's maybe a host. And on that host, locally, you're running a web server. Now, when someone goes to the browser and he types HTTPS, or let's say it's HTTP, depending on how secure the server is, you would then type either the IP address, and if you type the IP address, it would be something like this here. But if you feel like you want to type the name, let's say you give it a name, so you would say HTTP :/, and you would say maybe home .co.za, something like that, which obviously belongs to someone else, but I'm just making an example. Then that home.co.za would resolve to that IP that you see there. And that you would configure on the server instance itself. But then the DNS is responsible for reading that IP address entry and they call it the CNAME or the A record. And then with that, it resolves that to an IP. So if you go into the browser and you type the IP address, it will resolve that. And I'll show you that maybe later on Wiresock. Wiresock is a tool they can use to really just check how the DNS work and how you resolve things. And then the proxy server is more common. Proxy server is there just to cache all the information or the sites that you visit, and then it basically keeps a copy of it locally. So if the user goes to that particular site again, let's say it's this one, no name, he doesn't have to go to the real domain wherever it's stored. Let's say it's stored somewhere in another country. The proxy would have cached all the temporary files that's there, and then if the user goes through that proxy server, you will get that copy of those files. Only if the file changes, the proxy will then go retrieve that if there's further information that's added to that file, or another folder or another image that was uploaded on the server. And so that is your common application scenarios that you would use a server for. Can you run this on a normal PC? Yes, you can. However, as we said, the resources is important that you need to consider that all of these could run on one server and it could take so many resources and you would run out of memory, CPU, and even hard disk space resources. So that's very important that you understand really what makes up a server, why is a server different than a normal PC, and yes, why can't you can run one or two, maybe one of these servers on a PC and simulate it and test it. But again, it's all about making sure that all of this works on different services. And why I'm saying that, there's things that you learn later on. It's called TCP. If you don't know it, it's a Transport Control Protocol, and it's obviously UDP. And we'll talk about that because all of these services use that particular ports. They use random ports or they use specific ports, but all of these services make use of any of these. And these are, if you know the OSI layer, which I'll probably go through on network basics, and I'm going to just mention that now. So that basically is on layer 4, right? So layer 4 would be where this would work, and that's why when you go to a website, you will see HTTP, but it's actually port 80. So it's actually a 80 there, but you don't see it. The server sees it itself, the client sees it in the back end, and it's part of layer 4. And that's basically how information, allows you to connect to the internet. All right, so that is just basically giving you a scenario on typical scenarios on server applications. Right, so let's look at the development history of servers. So servers started very, very old, started in the 1940s to the 1950s. And that was the mainframe, those big stations, and with the mainframes, people just, use some of the resources because um, it was just very, very old and it was very slow also. But then obviously we evolve, to the microcomputers, and that's basically where we had the likes of Apple come into play, and also your x86 servers. That was basically the start of the computer. And that was the era where IBM launched their first CPU processor, and that microprocessor then launched Intel Pentium, and then after that you have all the different CPU flavors that Intel launched. And again, like I said, for the likes of Intel, for the likes of AMD, and also now ARM, which is also on servers. These three are important with regards to defining your server type and how the server will perform on the type of CPU, right? And because of that, that's why you have different vendors out there and different competitors that all compete, to give the client the same kind of resources, but on different, ways of how they do it. AMD is normally more gaming development for gaming servers, and Intel is more for the normal common, and then obviously ARM is now this whole way of how you want your server to run with less power consumption, and that's basically the different type of architectures. And then obviously now we have cloud computing, and cloud computing is where we're at. But again, this is just showing you the development history of where it started, how it actually evolved along the way to get to the cloud computing era. Now, when we look at earlier, I think early yesterday, we looked at 1.0, 2.0, and 3.0. This is just basically a refresher of that slide, but it just shows you how, in with regards to an image, what I said about KVM, because I remember I said about KVM, I spoke about all the different hardcore virtualization technologies that uses a lot of resources. And you can see here's an IBM server, and this IBM server basically sits in a data center, and it's probably way expensive, but it's there to be basically, a dedicated computing server. All right, and then I just want to double check if I can mute all new entries because I'm getting disturbance. At least that's fine. Just see something. I think the settings should allow you not to talk, so I'm not sure why it's doing that. But anyway, I'm not gonna bother with that. But okay, so what I'm saying is that the KVM is that that particular hardcore server that basically allows you to um, Let me just see if I can do that. So I'm just trying to see if I can actually do the unmute, but it looks like I can't. So I'll leave that for now. All right. So the dedicated computing that we're talking about here basically is the kernel virtual machine, and also hardcore, like let's say VMware, right? VMware is one of them, and that would be the VMware. I think it's the EXI. I can't. It's EXSI. Yeah, that's the one. And you have other big vendors also involved here. But this pretty much is how the dedicated hardcore resource you want to apply to a kind of cloud computing model 1.0. Then we have 2.0, and remember what 2.0 we said. This is obviously where you have general purpose computing. So you have your x86 server architecture, and you have your data centers. And so here you have the likes of OpenStack and all these other vendors that all play around together to really basically run that particular software on there. Then obviously lastly we have intelligent computing, and this now again is now really looking at, remember previously we looked at containers and cloud native, but this is now really looking at how they've looked at from a different perspective, that you have intelligent computing now, or full stack kind of computing stack, like a cloud stack. And so this is obviously where you have AI involved, you have GPUs involved, you have a lot of processing involved here. And that's basically the cloud computing model 3.0. Right, so that is just basically server types, giving you a history of it. And now we're going to look at different types of servers that you get. Now, these examples here are Huawei types of servers, but many other vendors have the same type of server base look and feel, the way it looks like this. So again, here you have a tower server that stands on a disk, so it's a tower server. And what it does is it basically have a lot of hardware resources in there. It's basically the same size as a normal computer, but it basically goes into a large cabinet in the data center. And then your common server that you get is a rack server, and this you can see there's like these holes here. That slides like basically there's like a rack that comes next to it, and then that slides into a data center cabinet. And so this is called a rack server because you slide them basically into a type of rack that you get. Normally, they call this a U1 or a U2, depending on the type of rack that you get, the standard cabinet. And then basically they all just slide into there, and you can basically program them. Not program, you can basically install your operating system on there. And then lastly, that you can see here's a blade server. And so the blade server, you can see that this is basically one big server with all these server components in here. It's called blades. And so it means that if one of these blades fail, you can just take out one blade, replace it, and the others will continue. But this is more for high performance computing, running multiple applications and even databases, because you want to make sure that that particular blade is dedicated to a certain hardware, memory, CPU, and so forth. So that's basically the blade server. And so all of these are common servers, but majority of people normally when they buy servers, they use this one because it's more common and it fits most data center cabinets. Now, there's the hardware that I just picked out now. So this is basically just showing you, the structure of a server, right? As I said, this is a blade server. I'm sorry, a blade server. What's the word again? A rack server. And so this is just a model of the Huawei one. You get Intel servers, you get IBM, you get Dell. Sorry, not Intel, so you get IBM, you get Dell. Um, I'm not sure if you get Lenovo, but I mean, there's a lot of gameplays out there with regards to server hardware. And so this is basically showing you all the bits and pieces of that particular server board. And so you can see you have a chassis, which is the whole unit. And that's basically the empty shell, which is here labeled number one. You have the motherboard, which is labeled number two, which is there at the bottom. And the motherboard basically have a lot of information that it has on there. So you have your CPU sitting there, your RAM. There's a lot of circuits and things that goes on there, right? But that's your motherboard. And then you have your memory. Your memory is your RAM, and your memory, as you can see here, in this picture, there's a basically just took it out so you can see what it looks like. And there you can see there's your memory modules, and then also here. And so this tells you that we normally have a PC with, let's say, two memory modules that you can put in. Even laptops, you can only put in one DIMM slot, or two at the max. A server you can put up to 64 different slots. Because it basically have two CPUs. So there's a CPU here, so there's a CPU here, and there's a CPU here also. So you have two CPUs that you can work in parallel, and then you have the RAM that can also work in parallel based on how many RAM slots you're going to use per CPU. And that is to equal, that's to balance the load of the server. So if one of the CPU fails, there's always a backup even on the server. And that's the basically a high availability kind of setup. Not high availability, but availability setup of the server. So I touched on the CPUs. Then the heatsink is here on top. The heatsink basically is that there. And so the heatsink is basically to cool the CPU. Without the heatsink, your CPU will overheat. And so that heatsink is especially there designed to cool the CPU. I'm going to try to zoom in so you can just quickly see in a way in what I'm showing you. Right. So there you can see there's the heat sinks. You can see there they have these pins there, and that pins will go onto the board with the CPU. And then you also have, number six would not being the power supply, the power unit. And what it means is that the power supply unit, the PSU, is that you can put in two or four, depending on how it is, how the server is built, so that you have kind of a, zoom out again, you kind of have a, they normally call this a power distribution unit. So it's called a PDU. And what it means is that if you have two, let's say power supplies here, PSUs here, and you have another two on this side here, and you have another PSU, you would basically have a power distribution unit that has like two racks. You would have power plugs here, power plugs there. Now my drawing isn't good, so there you have your power plugs, and there you have your power plugs. And so what happens is that this side is connected there, and this side is connected there. What it means is that if power goes down, if this one goes down, you have power still on your server on the other side, running on this side. And that is why the power distribution unit is so important when you have a data center, that you have two. So that if the one side goes down, there's backup, right? And so that is more or less how you would run a server. When we used to have, I think, load shedding. I think load shedding is now, we can't talk about load shedding anymore, might come back. But if you look at load shedding, you would have put it your one rack side maybe on your backup power supply, you know, and that would be, so if load shedding starts, at least this unit, this socket is powered by your either your batteries or your backup power supply, so that at least this stays on. And so that is basically how you would look at a server. So a server basically have all these components. You don't have this on a PC. Your PC have only one power supply. Your laptop also have only one power supply, and so that's why the server really stands out, differently designed for those kind of use cases. Right, so if you look at RAM, we've covered RAM, sorry. Then we look at fans. Fans basically is this here, number 7, right? So you would have, this is big fans, right? And this server can probably make a lot of noise when it starts up, because these fans are supposed to cool and for airflow. But when you look at this here, you could have a server where you have several of these fans mounted here in front. And if you look at this here, um, the air will obviously come through here, and it will go out to the back. And the fan's job is to take that heat from the front and then move it to the back. Why does it do that? Because in front, your hard disk sits here, your hard drive sits here all in front, and they tend to generate a lot of heat. So you would want to actually basically take that heat from that, use the fans, um, push that heat to the back, and then it goes out of the back, and that's how the server keeps its cooling mechanism. And so again, that is how the server operates. Like I said, number 8 should be the drives. It's here. Here's the drives. right? So these are the drives that I'm referring to. That's here in front. So these drives normally sit here in front, and they basically generate a lot of heat because remember drives they spin if, unless it's SSD, which there's not a lot of magnetic plates and spinning involved. But if it's a normal disk drive, hard disk drive, it will probably generate heat and it will spin a lot. And so that cooling part of that drive, the fan and extractor fans have to just take that heat and disperse of it. And then your air duct number 9 is right there at the back, and that's the air duct that I mentioned where obviously the air will go out. Because obviously, if you put the server together as it's now just taken apart, you can then basically see that that's how you would obviously combine the server and put it back together again. Right, so those are basically the server parts that I mentioned. Again, most services are designed like this. Some might have more add-on things, but this is just a common side of a server. Now, now let's look at a bit of technical side of things, basically on what makes a server stands out, right? And so commonly is the CPU. The CPU basically is there on the server. It's a unit, and so basically the server needs to have the high throughput. And because it needs to have high throughput and it needs to have like a robust stability and long-term running of that CPU, you need to make sure that the CPU really handles the performance the way it's supposed to handle things. And so again, the computer then makes sure that according to whatever's on that, what the CPU needs to function, it has some sort of controller. And so the controller here is basically the one that issues commands, that obviously from the input. So whatever input could be the keyboard, could be the display, it could be the software running on the operating system. All of that inputs, the controller needs to handle that. And that's why it's a special type of CPU that you use on a server. And then basically the CPU then basically have to determine, the amount of processes running in a computer. There's also a ALU unit also as part of that, and that's basically trying to do all the logic operations. So logic input, output. That's all things that runs on that. And also what it does is they use the gate features of AND and OR gates. So if you look at an AND gate, normally, sorry, let's do that. And so an AND gate is normally 1 and 0, right? That's normally 1 and 1. So you look at binary. So you have 1 or 0, 1 and 0, but that's obviously an OR gate. So that's an OR because it's a two features, it's different. But an AND gate is either 1 and 1 or you have 0 and 0, but it will cancel this out. So and just works with 1 and 1 on binaries. And so again, what it means is that as information comes in, it needs to really look at operations, do its thing of subtraction, multiplication, division, and that's obviously the thinking side of the CPU. But that particular unit there, the ALU unit, basically handles that part. And then obviously you have your register, and the register basically just stores information temporarily. So the CPU does a lot of things, right? And so it needs this register to store information temporarily so that, if it gets to the memory, right? Because remember your RAM is normally, this is not basically a proper example of it, but your RAM would sit here. Normally it would sit here next to the CPU, and then those two would be connected, right? When you look at your type of design of your motherboard. And so again, it's more about having information temporarily there before it goes permanent to memory, in memory, so that the RAM obviously contains all that information, right? Memory is also temporary, but again it's a long term that you would use the memory. And again, the register part there is basically just making sure that temporary data is stored as it comes from input, and then obviously with that it actually sends information out. So that's basically your whole CPU. What's the definition of it, how it interprets, sorry, instructions, processes, and many other things that runs on your server and even on your computer. And so that's basically just giving you the components of the CPU, which is those three units, and that makes up why we have the CPU designed the way it's designed. So you can also look at CPU frequency, and so CPU frequency um, is basically, looking at clock speed, right? So clock speed determines either in megahertz or gigahertz, and that just shows you how fast the computer needs to run. If you have the CPU that needs to compute and process all that data. You also have external frequency, and that's normally the speed of the motherboard. How quick does the CPU talk to memory? And that's normally they would call that external frequency. There's not a name for it. I can't get to the name now, but it's basically measured in megahertz. So it's not measured in gigahertz, it's measured in megahertz. So it's basically um, lower than obviously gigahertz because gigahertz is higher at the frequency. And so that just determines how information gets sent across the motherboard to different components on your PC. Then you have your bus frequency, and your bus frequency again basically looks at the speed of how the exchange is between your CPU and your memory. So your bus speed looks at your CPU and your DIMM. They two work hand in hand, and that's the exchange between the CPU and your dual inline module or your DIMM or your memory. And then your multiplication factor basically just how the CPU determines, what frequency to use to the external frequency. So normally if your CPU has, let's say 2.8 gigahertz, that's your CPU. Your CPU is that. Then maybe your external frequency again is maybe, let's say 1.8. This is making example um, gigahertz. And so what will happen is that the multiplication factor will basically look at the ratio and see which is the dominant frequency, to the external frequency, and then adjust it, accordingly. But again, those are basically part of how the CPU operates on your system. Memory, as I touched on it, memory basically is your RAM, and you basically have your main memory, and you could also have virtual memory, which normally sits on your external storage, but your main memory are commonly known as the internal storage because that's where everything you store, your programs, your everything runs on there. And that's basically what the CPU can address. Like I said, they work hand in hand. And memory is used to temporarily store CPU operation data. So as you get all the processing information coming in from what the CPU needs to do, the memory basically takes that bits of that information and exchange with external, with when you have external storage devices as hard drives and you use virtual memory. I think it's called virtual memory. You would basically use that to work hand in hand. Memory is important because obviously it communicates with the CPU. And you can see here, here's another example. So there's your CPU and there's your RAM. And you can see basically how close they are from each other. And that's how you have to design your motherboard. You can never put that further away from your CPU or RAM. Otherwise, you will have slower PC and slower operations. So all motherboards are designed that way for that perspective, so that your CPU are closer to your RAM. And then when you look at your memory again, there's a memory chip. So there's a chip there. There's a circuit card, and then the edge connector, which is here at the bottom, those gold plates. That's the edge connector, circuit card, and then obviously the chip on top of the memory. Those are the memory parts. Now you can see with the CPU, it also has three parts, but it's just giving you an idea of how the operation and the memory and the CPU work hand in hand. Um, yeah, so let's look at drives. Now we've covered a bit of, what's a CPU, the three functions of the CPU. We've covered memory, why it's closely related to the CPU and why it's always designed that way. And now we look at drives. So drives is also important part of your server, and so you get different types of drives. As you can see here, it's where you store your information or your data on your particular server. In this case, and so you have different types. You have SATA, you have SAS, and you have near. I think it's nearline SAS, which is similar to that. This is a different name, and this is Huawei's versions. And then you have your normal SSD. And so what it means is that for each manufacturer and whatever server operations you have to consider thinking about your drives. You have to think about the rotational speed, how fast that spindle goes, because that also determines your RPM, right? Your rotational speed. Uh, you have to think of also how the drive is operated. Is it in serial or parallel? most drives in the service serial, and in the capacity. How are you going to store data? Because later on we'll learn something called RAID, which is basically how you basically make sure that all your data that you store, you can either mirror it or you can obviously clone a copy of it onto another drive, something like that. Then you also have to think about when a drive would fail, what's its duration, lifespan, right? And so again, you have to think about the hourly time that drive could run for life when you would then think about replacing. Remember, your drives can never run forever. They have an end of lifespan, and when it comes to that, you need to be prepared. Okay, the question is, can I ask what type of drive would be the hard disk? So the hard disk normally it's a SATA drive, right? So it's a SATA drive. In the older days, you used to have a normal hard disk drive, but nowadays you have the SATA. All right, you can either have SSD also, which is a module, and you can even have a SSD as the same shape as a SATA drive. So in server operating systems, there's all these different types of drives, but it's also depending on the type of controller that you need. So the SAS that you see here is the SCSI that I spoke about earlier, and they have controllers that allows you to do certain things. Sorry, with their drives, and I'll explain that to you when we get to the storage side. This is just an introduction to it and just giving you a brief overview of the type of drives you get. Also have to consider the capacity of each drive, because you can see here basically that if you look at a SATA drive, you can get 1 terabyte, 2 terabyte, 3 terabyte, and that's a lot of space. But now you look at the SAS drive, you get less drive space. But what it tells you also, if you have a longer mean between it's called mean in between failures, right? So you have a longer, slightly longer span on your drive guarantee availability than your SATA, which is obviously more capacity. When you look at your nearline SAS, which is obviously Huawei's version, um, you have bigger storage space now, so this is slightly bigger than your normal SAS, but your lifespan, again, you can see also, again, it's slightly less than SAS. But then when you look at your SSD, the longest lifespan between failures, right? Which means that your SSD are guaranteed to run longer than any of these other three drives. However, your space is also less. You can see you don't have 4 terabyte, you have 1.6 terabyte, 1.2, 0.8, and 0.6. So it means that you you have longer lifespan but less space. What you need to do is you also have to buy more drives to cover, for the space you're going to miss out on. And that's again where it comes down to total cost of ownership. You need to consider that your drives are the most important part of your computer. Without that storage device, you have problems. You have slow drives, slow operating systems. And so again, these are just remarks, and it tells you basically the annual failure rate of these drives. But again, you have to consider what you're going to run that drives on, what type of operating system, what type of processing you're going to do on those drives. Okay. So those are, the common ways of how you would look at different drives with regards to the speed. Now, we look at SAS here, SAS basically, and nearline SAS. We're going to go next. The next one will tell you basically really why we have the SAS. So this is a RAID controller card, and so the RAID controller cards goes also onto your motherboard. This allows you to have your drives in that base to become RAID controlled. Now, what we mean by RAID is that you have maybe one drive I can draw, right? You have another drive, you have another drive, and you have another drive. That drive then is connected to the controller, which is here called, this is probably the RAID. Um, I'll just call it RAID C for RAID controller. And then these are all connected to that controller. What it means is that if you want to configure these different type of RAIDs, and we'll get to the different types of how you configure RAIDs, you get RAID 0, and you have RAID 1. What it means is 0 means that you can add all of these together with the controller, and that will be your space. So you create one logical drive with all these different drives. So let's say this was one, that was one, that was two, and that was two. So what we're saying is 1 terabyte, and that's maybe, yeah, 1 terabyte. You always want to have them equal, but I'm just making an example. And you have 1 terabyte and, sorry, 2 terabyte and then 2 terabyte. What it means is that you would add all of these together if you want to use RAID 1, sorry, RAID 0. So you would say, add those two together, you have 2 terabyte, you add those together, you have 4, and you plus that together, and you would have, a total of six terabytes, right, in total. But if you look at RAID 1, there's a feature of RAID 1 that's called mirroring. So what it will do is it will mirror your drive. So you would have this 6 divided into 3, and that would be that you have a high availability. So if this drive goes down, there's this drive still running. If this drive goes down, there's that drive still running. And that is basically why we use RAID. Okay. So that is basically just, now we will get to that in detail, but that is just basically showing you how the RAID controller card is being used on the hardware side. And then obviously you have the software side where you can do it also on your own PC if you didn't control the RAID from the controller. Right. So again, it combines multiple drives into one system, according to how you, as the administrator, will configure those drives, and that obviously improves your, performance and reliability. As I mentioned, the mirroring part. There's other RAID levels that we'll go through, which is the highest. I think is RAID 5. There's RAID 10 also. But RAID 5 and 6 are common. They allow you to have disk checking, error checking. So some of the storage will be going for checking errors, so that you obviously have this whole reliable kind of storage side also available. Right. So those are, just the scenarios I'm giving about RAID. Now, there, I just showed you now in my pictures here. It's a proper image of that, what I just showed you now. So again, RAID, as I said, stands for Redundant Array Independent Disk. What it means, they're redundant, right? Anything can happen to them, but they are also in an array, which means they are all together, bind together in an array, and they're all independent disks, right? So that's what it stands for, RAID. Now, again, with server operating systems, you have all these different drives. So these are physical drives here. So that's a physical drive, that's a physical drive. And so you can see there's 4 physical drives here on this particular server example. And so what it means is that you can take all that individual drives to the storage virtualization technology known as RAID, combine them all into one physical disk, which is called a logical unit, right? And that logical unit then allows you to have data redundancy, performance improvement, or both, right? So you would then combine them into a virtualized logical drive. So they're not really physical. It's not like you take all these drives, you could put the cables together and combine them. No, you basically use the RAID controller, being that it's software or hardware, and you virtually, so this is a virtual logical drive, and you bind them all together, so that you have all of that running together, right? So that is, yeah, the virtual part that I wanted to cover on that. And so when we look at all of this together, you now have the implementation of it also, right? And so you now look at the RAID implementation where I showed you the controller card, which is here, and you have your drives here. Remember, this is your physical drives. These are all physical, just making the letter P to say that it's physical. And then you have this SCSI bus, which is this bus that communicates with the controller card. So all these drives here would all communicate with this controller card, and then this is basically a example of a server that's built in with a card, right? So you have your PCI bus here. We saw the bus, what the bus determines on the speed, and then that controller card then communicates with the CPU, and then the CPU does its functions. So again, that is just basically when you have a RAID controller card built in. When you look at the other example here, which is the second one here, you now have an independent drive array. What it means is that Your drives is still there. There's your physical drives. You still have the communication from the bus to the controller, but now you have independent. You have now a SCSI bus. Here you had the SCSI bus and the PCI bus. So you had two buses you had to operate on to go through to the next phase. Remember, without the bus, the RAID controller card can't communicate with the CPU. But now in this RAID mode here, you have one SCSI bus and you have a SCSI card. That's now obviously, and you have a PCI bus, but you can see basically here, this is basically a card that's connected to your CPU. And that's a different side of how you look at it. One is you have your drives all, number one, you have all your drives here, and then you have a RAID controller card. The other one here, you would have the RAID controller and not the card, and the controller will then manage the whole process. So those are types of services that you get, and it depends on how it's built and designed. Um, and also, these are commonly used and commonly known as hardware RAID controllers. And that's basically how servers are built. When we look at implementing the software side, right? Because you get software RAID also. So software RAID basically looks at installing software on the operating system. So you can do that at the start of installing operating system. On Windows, you can do RAID. On Linux, you can do RAID, but you do it from the operating system side. And so what it allows you to do is you don't need an expensive controller card because these RAID controller cards are expensive. I mean, HP controller cards, just for that card, you pay about 15,000 just for the card alone. That's not even the drives that you have to buy still. So these cards are very expensive because of their job and the features that they have to do. And so again, if you have software RAID, you reduce your cost, right? So your TCO, total cost of ownership. But again, you have to configure, that RAID have to use the CPUs have to do all that features now. Whereas you had your RAID controller card that acted as a CPU for the drives. So now your CPU then have to use more resources because you now have adding more resources to CPU. And then mainly if you have a RAID 5 kind of operating system, which would have probably about 10 drives, if I'm not mistaken, but we'll look at that. 10 drives or 5, depending on how you look at RAID 5. And that basically means the CPU have to take all that whole processing now because you don't have a RAID controller card. So those are two scenarios. You have your software RAID, which is implemented by the CPUs. So the CPU usage is high, which means leads to reduced system performance because now your CPU has to act and organize all those drives working together. But advantages is that you have a low implementation cost and it's flexible to configure because you can do it from the software side. You can go delete that RAID if you need to delete it. There's no control involved, and you can just spin up a new type of RAID you want to have. And we'll get to the different types of RAIDs later on. You also have built-in RAID, which now again improves the performance, and then your CPU usage is obviously used less because then obviously you don't use all these intensive RAID operations. Your data protection, your high speed is then improved. You have something called fault tolerance, and then your performance is also improved. And then lastly, you have the fact that it's more cost effective than external RAID. And so if you look at external RAID, this is obviously where you have the external RAID where you connect to a server through the controller, which you saw previously. Just gonna give you an idea. So there's your external RAID. Here's the controller. And so with that, you have an independent operating system that runs, and then the RAID controller does all that whole processing. But again, you have, you know, more storage that you can use. You could have dual controllers also. And you could have hot swapping, which means you can swap up different controllers with different drives. So you have better scalability. So there's this whole scenario where you have to think about which one you're going to use, right? So that is right. Now, I see we're 5 to 10. I think let's take a 15-minute break. We can start then quarter past 10 again because the next one I'm going to look at is the whole encapsulation on the network card, and then we'll continue with that. So we can take, yeah, let's make it, let's say it's 5 to now, let's make it 15 minutes break, and then we can continue again after 15 minutes. So we will make it 15 minutes break. So we start again, let's say 10, well, it's 5 to now, so, but let's make it, yeah, let's make it, we can say 10 past 10 if we count what's running now, so we can start again at 10 past 10. Yeah, okay. So we do the 15 minutes break till 10 past 10. All right, and then you guys can now just think about what you've now just consumed all the information, and now just think about how the server works before I head to the TCP/IP and what's your network interface card. Thank you. Right, we're back. Okay, so we basically paused on moving before that. Let me just go back to my slide. So we stopped at software rate. So just to give you a bit background on this. So remember we talked about you get a software rate, which you can do with your operating systems, and then you have a built-in rate depending on the server type. And then you have an external rate, which is the controller card. So those are the different rate implementation scenarios you could have in a server environment. And you have to decide as a server administrator. And so why are we telling you these things? Because all these cloud providers have to do all these. They have to have their way of how they do the high availability of the drives. Because if you don't rate or mirror your drives, a drive could fail and you would have all the worlds of storage, but you would run into problems with guaranteeing availability of that data. And so hence why we normally do the rate implementations. Now, get back to what's a NIC. So NIC is your network interface card. That's your network interface card, and it can be a card embedded onto your server. Normal standard service comes with four of those NICs, but you could also have, a network adapter, which is this card here. And so what it allows you to do is this would fit into the motherboard or into a type of riser card, depending on the type of server. And you would see here in front would be your network, your cables will go in there, and that would be your network card, your network interface card. Now, when we look at the network interface card, it's there to allow your server to communicate with other networks. So the functions of it, it has obviously a fixed network address. And what we mean by fixed, we mean the MAC, right? The MAC address. So it has something called a MAC address. And the MAC address basically is a unique hexadecimal bunch of characters together, and that defines the fixed network address that can never change. That is by default what each network card have based on the manufacturer. Then you have the features of sending data and receiving data, and that's also part of it. The encapsulation and de-encapsulation, when we look at network basics, we'll cover that in detail. But the encapsulation means that it takes information from the previous header, adds it together, and sends it through its processing. And I'll explain that in the graph, which you see here. And then you have de-encapsulation by removing the data again, per layer. And that's basically how you're actually not removing the data, you're removing the headers per layer. And then obviously link management, it needs to make sure that the link is active. Otherwise, you won't be able to get information out of the server. And then obviously encoding and de-encoding, and that's also important because it basically have to encode information and then decode it based on how information travels on the physical line, which is here at the bottom. Right, so that is basically your network functions, network card functions. And then so when you look at this here, this is your typical TCP/IP layer. So you have a physical layer, which is ones and zeros. So ones and zeros, so binary basically would be at the bottom. So this is when you convert everything to ones and zeros, depending on the type of length of this information that gets sent. But information gets sent in ones and zeros over the cable. What we mean by cable, it could be your Wi-Fi, or it could be a network cable, it could be a fiber input, fiber cable, it could be satellite, be any way of communication. That's what happens on a physical layer. Your data link layer deals with your MAC address, so your physical network addresses. So it deals with adding a MAC address header, and so when you look at this here, this is basically a encapsulation process happening here. This is encapsulation. What I mean by that, this is encapsulation, is that you're adding all these headers together before it gets sent across the network to the next wherever it needs to go to. So you have your data, your sample data that's there that never changes. And then when you get to the application layer, it goes to the transport layer, it adds a TCP header. So your TCP header would be ports. So it will add a port there, port numbers, whatever it is. And it would be the source and destination of the port numbers that will be added in there. Then it goes down to the IP header. The IP header then adds the TCP header also as part of its communication, but it adds the IP address. What's the source and destination IP address? It adds that also there, and that goes into the IP header. Your data still stays the same. Nothing happens to the data. And then when you get to your data link layer, which is now your layer 2, you now have your MAC address header that deals with source and destination MAC addresses. And it actually takes the IP header information also and the TCP header information. So it combines all of that, into one particular header, and then that gets sent across the network. When it gets to the other side and it needs to de-encapsulate, it now removes all these headers, and also that to you in the network basics course and slides. So those are an example of a typical encapsulation, and this is where your network card have to handle the de-encoding and the encoding part based on how information gets sent across. So you would use your network layer only here on layer 2, and you would use your network interface card would be there. Your network layer would be either router or switch. um, and so depending on where information comes from, that's basically where the IP address lead. But remember, your computer, your server has all these layers together, because it could be a server and it needs to route information, so it not necessarily be just the router or switch on that layer. Now let's look at server types. You have different, network interface card types. You have different cards. The common ones we get is your built-in. So you can see here you have 1, 2, 3, 4 network interface cards. And you would have one there on top there, which if it's Intel, it will be called an ILO. And your ILO is there to remote into the server. So that ILO is there to remote. But then you also have other cards that you get here. So this is this physical LOM card, meaning it's directly onto the motherboard. You can't get that separately. And then you would have your PCI Express card, and your PCI Express card would go into your motherboard as well. And if I zoom in here, you would see that it's basically um, two inputs that goes in there, and that looks like fiber input. So that will be a fiber cable that will go in there, or it could be a gigabit cable. I think this is fiber here. I'm not sure what that looks like. That's also fiber. You can see there's a fiber input, but it's a different shape and design. But what you see here basically is that this could be a normal category 6 cable, but it could be maybe 100 gigabit speed, 40 gigabit, or 10 or 20, depending on the type of card. So those are, when you look at your network interface cards, you get different ones. And so as I say that, it could be the standard one here, which could come out with 1 gigabit speeds only. So normally they would have only 1 gigabit connections. And then you would have you actually have to write like that, gigabits per second. And then you could have a card that has 10 gigabits. Now when we look at that, you could have two of the 10 gigabits, or you could have both, or you could have all four would be 10 gigabits per second speed, right? And why do we need four? You might want to create virtualization, or sorry, VLANs. And so then when we look at network base, you'll understand the concept around that, because you might want to use two of these NICs for storage, right? So you want to say, let's say, okay, I want my storage servers, wherever it is, to just use this part of my server for storage. And you want these two maybe for management. So you want to make sure that you management and how your servers connect and talk to each other, it's only on that. So what it means is that you've basically separated your type of physical network, or the way the card operates, so that your cable that goes in there, it's only connected to the server side, I'm sorry, to the storage side. And the cables connecting there is maybe connected to the network, the normal network, the switch, and that switch connects all your switches and servers together. So that's kind of how you want that setup to be, if you look at you utilizing all four. And also what it makes you do is that when this is 10 gigabit, so let's say that's 10 gigabit bit per second, so that's 10 times 4, you would have 40, right? 40 gigabits. So that's a lot of speed, right? Now if you split it, you would have 20. So it leads you to have a 20 bonded link, for storage, which means that the bandwidth of that link is basically 20 gigabits per second speed. So it's faster speed that you've added by combining it. And so you can do hardware bonding or software bonding. And we're not going to go into any detail, but that's basically what you can do when you look at that particular setup there. Right, so when we look at PCI Express card, Huawei has its own particular card that it developed. And obviously they can be installed on a normal PCI slot on your motherboard. You have a Flexi input output card. IO stands for input output, the abbreviation or the acronym. And so it's Huawei developed also. It's not the normal standard PC card. And you can only use this card with Huawei rack service. So it's basically a card designed for the Huawei services only. And many manufacturers build the cards based on what they want to use it for. And then again, you have your mezzanine. I think it's probably 9 cards because it probably have 9 inputs, but it's mainly used for compute nodes on Huawei Blade servers. So it's those Blade servers that you saw in the beginning where you slide all the servers into one container. So that card is basically only used for that particular service, this card here. So these are just common Huawei cards. The common one is the one I've basically spent the time on that I showed today on top, which is your LOM card or your physical card that's onto your motherboard. Now, if we look at power supply, we've covered that earlier. Where I showed you, the different type of power supplies, and not the different, but why we use, your PDU, your power distribution unit, and so again, it's basically to support redundancy and to prevent power supply failures. So again, it has some of these units have this thing called on top of it, and so what that means is it has kind of a monitoring feature on top of the power supply. It then prevents, if there's any faults, it will prevent that because it will alert you that your power supply is either running high or it's running low. So you have this constant monitoring embedded and reporting from your power usage and consumption. And also are there to prevent any maintenance so that if you have to go into maintenance, it will obviously alert you before you even go into maintenance. So it has a pre-fault preventive maintenance kind of scenario. And it obviously is non-disruptive services, so it doesn't actually disrupt your services that runs on your server. So with that, you have basically intelligent power supply unit, which is this here. So this little, I think this in front here, it's the intelligent part. And then you have your normal fan module, which is just what you slide into your server for cooling, right? So those are the fan module. This is an handle that you would hold and you would slide this into your server. So these are, scenarios of, when you use it. So you could have a one-on-one where 50% of the output power would be from one unit and the other would be from the other unit. So what you would do is you would design this in a way, and servers are designed that way. So you would have a power supply unit, so I'll just call this a PSU and another PSU. And so maybe this is connected to your server, right? But what you would do is you would say, okay, while these two are actively running, only 50% would be powered, from this side, and then 50% from that side. So you basically cut your power consumption in wattage into half of what you would have done. And that's where you have this intelligent side of it. If one is removed, let's say one goes down, that 50 then moves to that side, which means then you have 100 um, power supply usage on one PSU if this one have to go down, right? So that's kind of the PDU kind of setup that I mentioned earlier, but also how you look at your power supply. And obviously, if you look at 3 modes, let's say you have 3 devices, you obviously have to consider that if there's 2 remaining, then at least you can have that in 50% as the previous example that I showed you. All right, so those are scenarios of when you look at a data center. So key things from that is that many network administrators or network administrators, many infrastructure so support as specialists have to go through that and really understand how that works so that they make sure that the servers are always up and running. So what you see now is the IPMI, and this is similar to what I said earlier on this part here. Let me just try to um, highlight that the different colors so you can just see what we're looking at now. So this part here, this card here, where I said ILO, in that case, ILO is not the Intel term because Intel uses ILO, but Huawei uses IPMI. So it's Intelligent Platform Management Interface. What it means is it allows you to remote into that server wherever you are, and you can do configurations on the server remotely without having to be in the data center. So it's basically using a baseboard management controller, the BMC, in order to remote. So here you would be the client, not really the client, but maybe the admin, because you're the admin and not the client. And then you basically then connect and you manage the server through that IPMI, which is then embedded onto the BMC, which is on the server motherboard. That is basically allow you to remote into your server wherever you are to configure it and do certain configurations. You can then check and see the state of the server, monitor the temperature, check the voltage, fan status, power status, even do remote installations also on it. So you can do a lot of things on it by using that particular IPMI controller. So BMC, when I said, is basically just one of the features. It allows you to have a remote control. You have the alarm management, so it has this alarm management on the server that checks and monitors and give you updates and feedback. And it's a web-based management, so you don't have to worry about logging into console. You just go to the URL, the HTTP URL of that server IP, and then you can basically control and manage certain things that you need to do using that. And so the features of the BMC, which is called now the Huawei Intelligent Baseband Baseboard Management Controller, which is an I in front, is basically just on Huawei services. So Huawei services only use this particular thing. You won't use this on Intel or any other manufacturer. But again, it's also based on who's the provider. So again, it does status monitoring. So you can monitor your CPU, your RAM, everything you can monitor. It has fault diagnosis, which means that you can basically check for faults. If the temperature is overheating, you can check that. And also the storage medium faults, if there's any problems with the drives, it will alert you and tell you that. You can run records also on it. You can do updates also on it. And you can also act as an assistant, so you can ask it to power off certain things, do screenshots, record videos of the setup of the OS and so forth. It does all of that inside the controller. And so they basically developed this for that use case, so that you can make sure that we need to configure the server and do all this deployment and that there's, you can even record what you're doing so that you can go back and fix something if you maybe configure the wrong thing. Maybe you configured RAID and you were not supposed to configure RAID. You can go back into the video and really go see what you've done, and try to trace your steps back, and and then see how you can use that. Right, so that is basically, we've covered introduction to services. We looked at key server technologies, and now we're going to get to our BIOS. So our BIOS is your normal basic input output system. All computers have this BIOS, and what it does is it does some checking when you start your server. When you switch your server on, it goes through the BIOS, checks the system information, and it goes through the whole process as you can see here. So what it does is it checks your hardware first, that the hardware is intact. It checks your display, your memory, your keyboard, all those things when you switch your PC on. And then again, after that, after the BIOS does all that check, it checks your kernel of your operating system if it's correct. It checks your operating environment of your operating system, and then it checks some applications that's needed, maybe. But those are the key things that your BIOS does. It checks when it starts it up. It does all of this checking. You have your post, which your power and shelf test, which basically let's go through that. But I mean, your BIOS is there basically to make sure that all your programs you're using are grouped together. It manages everything, and as well as making sure that it's there to handle faults if there's any faults also, and even password protect your operating system before you get to the operating system. So your BIOS is basically a foundation of a lot of programs altogether that you would use for your server. And I think that covers this part on storage on server basics. So again, it's more or less just looking at what a server looks like, and seeing basically what you can do and what you use it for. And so if we look at these questions here, so the question here is which of the following statements are true about your network interface cards of Huawei servers? We're talking about Huawei servers here, not any other server. And so the first one is the LOM card. Remember, that's that 4 card that's embedded onto the CPU, and the chip on the server mount cannot be replaced. And that's true. Remember, that is embedded, so you cannot replace that. So that would be right. The next question. Huawei developed PCI cards that can be installed in standard PCI slots. That's also true because you saw earlier that they have these custom PCI cards which you can install in your normal PCI slots on the particular server. So that's true. Then your Flexi input card, that Flexi card that we saw there, is integrated into the server panel for a front end service connection. That's false. Your Flex input card is a card that's separately there, that's available, but it's not integrated. So here they would have tricked you into think about integration, and it's not integrated, so that's wrong. And then the mezzanine card, which is that other card, can be used with Huawei rack services. That's also wrong. They're catching you out here. You need to know your 3 different server types. So it's Huawei rack, you have Huawei blade, and you have a Huawei tower. So the answer here would have been blade. Then this would have been right. So it's wrong, right? Because that's a rack. That's not a blade. And so again, that is basically how they would treat you in certain questions. And then the last question is the PMC complies with the specification. It collects, processes, stores sensor signals, and monitors component operating systems. And that is correct because we saw now the functions of the broad what's called the control, the BMC, and how it basically operates on that case. So that, students, is the end of server basics, covering all the server basics, looking at how things are run on the server side, and also just really understanding how the server operates as it is, the way it's designed and how it actually works. So that covers that part. I think the next part we'll look at network basics. I think we already took our 15-minute break. I don't know if you want to take a breather, or we can just jump into the next topic. And then we just continue with that to maybe to half past. We will probably finish at 11 today, which we started at 11 yesterday, but we'll probably finish at 11. But I think it's just to cover the basics. This is not the full intensive course. It's just to give you the 4IR side of cloud basics and really understand how the cloud works. And so we'll just do all these bits and pieces. So again, I'm just gonna just jump to the other slide. I'm just gonna stop sharing. And then while we stop with that, can we just take our photo again before we start the next session? So I'm gonna ask you quickly just to switch on your cameras again, and then I'll just quickly take my attendance, and then you can switch off again. So we can just spend 30 seconds just quickly doing that, and then I'll share the other slide. So you can switch on your camera, and then we can just quickly take that quickly. All right. Okay, I'm gonna take the screenshot now. Thank you. Right, I'm taking it now. 1, 2, 3. Let's see if I captured everything. Okay. And then I just want to take another one, other side. Okay. All right, thank you everyone. Thank you. So you can switch your cameras now. It's fine, thank you. So I'm gonna just pull up the next slide. Sorry, I'm muting myself. So I'm just gonna pull out the next slide, and then so we can just quickly just see what's the next part of our topics. Just see, because we're doing basics, so I have to keep that in mind. So we've covered cloud basics, we've covered server basics. The next one is storage technology basics, yeah, because that is to show you basically how RAID works. So I'm gonna open up that and then play from start. Right, so let me just share my screen quickly again. Okay, so now we're going to look at storage technology basics. And so, with regards to storage technology basics, you have this whole understanding of really what makes up storage work. And so, we're going to go into detail as to show you really how you can store storage in where you can store storage on a server side platform. And you'll learn something about other ways of how you can store information, where you store it, and how you store information. All right. So data is very important, right? It's an important asset for every enterprise. And so in this course, we'll describe, how the storage is used, where it's stored, and also just look at key storage the data technologies in cloud computing. Sorry, I just want to do this quickly with the recording. I'm going to split the recording to two so that we don't have a long, so we have it like almost like